right? A approaches
From the right.
whatever this number is from the right.
Right.
That makes sense?
It makes sense.
Sorry, kind of.
Sort of, kind of, maybe?
Yeah.
Yes, no, maybe so?
Yes.
Yes, so.
Let's start off with an easy one.
Yes, maybe yes.
The other class was freaking out. This is the first exam.
Really?
Like last time on.
So this one has a vertical asymptote
What the hell's pieces?
in between, right? So be careful. Remember to be vigilant. So look at this guy. If I write the integral from 2 to 5 of 1 over the square root of x minus 2, it just looks like a regular definite integral that we've seen before, right?
Yeah.
It doesn't seem to be improper.
Wait a minute. Put 2 in there.
Wait a minute.
Put 2 in
What's
there.
the problem now that we're being more vigilant?
At 2 there is a verb.
At 2 there's a vertical asymptote, right? We never even checked for that before, right?
Yeah.
So weird. Maybe we should tell the AB teachers to start teaching.
Wait, isn't that you?
Oh yeah, my bad. So the vertical asymptote at x equals what?
2.
2. So is this guy farting in the elevator?
Yeah.
Yeah.
Silent, but silently.
This is the one that farted in the elevator, right? He was hiding. But we got him, Alright, so let's deal with him. How would we set him up?
Let's kill him.
We got
Limit
the limit
as
as
N
no,
B
nope.
A.
Could we have used any of those letters? Yes, but A, I just like A, right?
Freaking gone.
Anyway, as A approaches what?
2 from the left.
2 from the left?
Yeah.
Can we approach 2
No.
from this side?
No.
No, we're in this interval, we can approach from here, so
It's
from the
case
right.
2.
Case 2, right. Approach 2 from the right of the integral from where to where?
A to 5.
A to 5. Can we rewrite this guy?
Yes.
Yeah.
X minus 2 to the what power?
What a piece, Caroline.
So far so good? Can we integrate him pretty easily?
Of course.
Yes.
2,
So if we make this u, what's his derivative?
1.
1, we don't need anything extra because it's there, right? So it's that to the what power now if we add 1?
2 to
1/2.
the square root of
X minus 2 to the 1/2 times 2, bless you. Evaluated from A to what? 5. Good?
Yeah.
Plug in the 5, so what's 5 minus 2?
3.
3, so we get 2 radical 3,
The radical, man.
yes? Minus, plug in the A minus 2, well that's just 2 square root of A minus 2, yes? Now we still need to take the limit as A approaches 2 from the right. So what is that going to affect?
The right side.
It's only going to affect this part, right?
Of course.
How do we do limits from one side or the other?
You get a number bigger than it by a little bit.
We do? We can't just plug to it?
No.
What?
It's right there.
Why not?
There's a
Because
vertical
it has to be to the
asymptote.
I thought we could do that with one-sided limits, but isn't that what we do with all limits?
No.
No.
Just plug in, and if it works out, we're good,
If it's not, I mean.
right? Let's see, plug in 2. 2 minus 2?
0.
0, square root of 0?
0.
0 times 2?
0. But
Oh, it worked
yeah,
out.
but like.
Awesome.
No, wait, it's
So
not.
it's 0.
No, hold on.
2 radical 3 minus 0, so what do we get?
Oh my, he got me.
2 radical 3, right?
Of course.
Does it converge or diverge?
No, convert.
Converges.
Wait, what?
I really don't understand.
Yeah, I didn't get that part.
Yeah, I didn't. Wait, so did I? When is the only time we have to consider something actually from the right side of 2?
Over a fraction or like
If
what's the word?
If we end up with something after direct substituting that gave us something that would be
Yeah.
undefined,
Yeah.
Wait, did you plug in?
okay?
Yeah.
If I get undefined, then I know that it does not exist right away, right? But because it's a one-sided limit, they don't want you to put does not exist. They want you to put the infinity that it actually is, right? So in those cases, you have to pay attention to the graph and decide where the graph is going, right? Or pick a number close to 2 but on the right side just to figure out the sign. I don't know if you remember doing that.
Yes, I
We would
remember.
figure out the sign and we would just either put positive
Positive,
infinity or negative infinity, but we knew it was gonna be an infinity. Why? Because by direct substitution, we got something that wouldn't give us an answer. Does that make sense?
Yes, big
Yes?
sense, big sense.
Review, it's our 1-year anniversary of one-sided limits. This time last year in AB, you were learning one-sided limits, right?
Happy anniversary, Mr. Science.
Happy anniversary, calculus.
You're all babies.
Oh, good times.
And I'm doing this.
Happy anniversary.
Infinity of
Hey.
Good, good.
It's your birthday today.
It's a baby 14.
Yeah, you were probably learning the same
English recipes.
Day 14.
Good.
She's the principal of freshman year.
Another one?
Another one.
No,
Another one.
except that one.
Alright, let's do another one. Yo quiero dinero.
No. Ew, that's fine.
The integral from 0 to 27. That's pretty normal. It's like a normal dude, just
Hold up.
on the elevator with me.
On the other.
Right?
Oh no.
Or maybe it's a girl, right? Looks
Randy
like
Orton,
well, that's a pretty girl in the elevator. Look at her.
Hey, wait a minute.
Eee.
She's farting though.
She's farting on the elevator, man. Oh,
He's like,
I hate it. Why? Why does she have to be pretty and fart? Alright, anyways. So, how do I know she's farting on the elevator?
Because it's
47
it's
like
zero.
zero.
You plug her in, it's like a zero on the bottom.
So we're being vigilant, right? And we find out that we have a vertical asymptote where?
X equals 27.
And x equals 27, right?
Oh my. Oh my.
Is negative 27? Positive 27.
Yeah, but then we
No, he
take
likes
out.
crap.
Who does?
Well, remember, it's what you plug in there. It gives me 0, cube root of 0, 1 over 0 makes it
So I
undefined.
meant to joke, that is new.
Yeah.
Yeah? Good? Alright, so the problem is at one of the endpoints, and this one it's at the upper endpoint, right?
Yes, sir.
Alright, so let's see if we can do this guy. E is improper. So limit as what?
As
The approach is
B.
27.
No.
Approaches 27.
From the left.
From the left, that's the only side we can get to him, right?
Of course.
We don't know anything on the other side of it.
Integral.
The integral of 0 to b.
The integral from 0 to b.
At the
And then we're gonna rewrite,
Rewrite it, okay? 27 minus x to the what? Negative 1/3. Beautiful.
Oh, yeah.
Come on.
That's a cube root. And this is a minus, don't think it's something from the other side of the cube. Good?
Yeah.
yes,
Alright, so can we integrate this guy pretty easily, or do you want me to do some side work?
Oh, 3 over 2.
Side work.
3 over 2.
Side work? Okay, so what would be this guy's derivative? If you were you? Negative 1, do I have the negative 1 there?
no,
No, so I need to correct it by adding a negative 1 and then adding another negative 1 out here. So I need a negative 1 on my answer, right?
yes,
Yes, no, maybe so. So let's do it. So this is 27 minus x to the negative 1/3. Well, if we add 1 to that, what do we get? To the 2/3. We multiply by his reciprocal. And remember, we needed to add a what? A negative, because there was no negative. So that should be the antiderivative. Negative 3 over 2 parentheses 27 minus x to the 2/3. Why is it negative?
Why'd
you have
negative?
Because if this is u, his derivative is negative 1. I don't have a negative
Hold
1.
up. Oh my, look at, I'm sorry.
Are we okay?
Yeah.
You with me? Alright, so I'm going to leave the negative 3 over 2 out. Okay, I'm gonna plug in b, so we get 27 minus b to the 2/3, right? Minus, plug in 0, 27 minus 0, that's just 27 to the 2/3, right? And we still want the limit as b goes to 27 from the left for that. Can we do this side? What's 27 to the 2/3?
81?
81?
Because you do the bottom one.
What is the bottom number of the rational exponent?
It's
It's
cube root.
the roots, right? Where do roots grow on a plant?
On the
On the
bottom.
bottom for most plants, right? So that's the cube root, in this case it's easier to do that, cube root of 27, 3 and then 3 squared,
81. Oh, just
9.
kidding. I'm dumb.
Whoa. No,
I
you're
did
not.
27 divided by
You're
3
40
and that
pounds.
time.
Yours,
I'm
Okay.
sorry.
Alright, so now let's do this side, okay?
Alright.
That's the part that's gonna involve the limit, right?
Yeah.
So what do we always do with limits?
So
Even if they're one-sided.
evaluate.
Evaluate it, plug it in, right? 27 minus 27?
0.
Yes, 0 to the 2/3?
Yes.
0, so that's just still 0.
Yeah.
0 minus 9 is negative 9, negative 9 times negative 3 over 2 is?
Negative 27. No,
27 over
2.
27 over 2, and if it's practice for number sense, so let's write this as a mixed number.
No.
Yeah.
What would this be as a mixed number?
31. 31 half.
13 and 1 half. And let's practice, how do we write that as a decimal?
13.5.
You guys are good.
13.
Can we do it?
Excellent. Not that you need for calculus,
Oh, my bad.
right?
I
Calculus is
confused
easy, you can stop there.
Thank you.
Number sense, you know, it's the real challenge.
Yes.
Good? We didn't take a number sense quiz today, you want one?
No.
Yeah,
Yes.
yeah, right? It grows on you, right? You start to like it?
No.
It's like, it grows on you.
It grows on you, right? It's like a fungus.
Oh my god. I just over here like this.
Alright, let's try another one.
I like them because they're not for green.
I want to get 50 likes. 50 likes.
And the ones that go up to the window.
Let's try this guy, here we go. Integral from 0 to 1,
Oh no.
Is this the normal?
and we haven't done one where it happens in between, right?
No.
We'll do one of those right now. The integral from 0 to 1 of ln of x.
Easy.
It looks like a normal
Wait a
definite
minute.
integral.
Someone's hard 0.
They're farting?
It's 1.
Oh, what's the problem here?
ln of 1 equals to 0. Wait a
And
minute.
then a 1 equals to 0, that's not a
It's
problem.
not, it's 0. It's 0.
And then a 0, right, is undefined. So this guy has a what? An infinite discontinuity, aka vertical asymptote at
0.
x equals 0, right? If we imagine his graph, he has a vertical asymptote at 0, he gets really close to him but never touches it, right?
Maybe that way.
Cool? So what we're trying to do is we're trying to find out, is there a finite number that we could use to represent this space here, right? From 0 to 1, so only from 0 to 1. Would there be a finite number to represent the amount of space from 1 to infinity?
No.
No? Why not? What would that space just keep doing?
Growing.
Just keep growing, right? So what would it do if I had the integral from 1 to infinity of ln of x? It would diverge, right? That area would just grow infinite. It would go pretty quick. Cool?
Yeah.
So we're looking at this space here. Yes?
Of course.
Alright, so let's see what happens. How could we do this guy?
The limit as a approaches 0 from the right.
The limit as a approaches 0 from the right, okay?
Of
The integral
x,
of
ln
a
of
to
x. Oh wait, I'm sorry.
Of the integral
8 to 1.
from a to 1
ln of x dx.
ln of x dx. Oh, you were jumping ahead already.
Why
So what's the
right?
integral of ln of x?
X ln of x minus x.
X ln of x minus x.
Memorization.
Memorization, right?
Yes.
We did that one on an assignment, we also did it on the notes, and it was also on one of your quizzes, so you've already seen it several times, right? It might be a coincidence, or it might be that,
It might be on the
it might be important, right?
Might be a
How do I do it if I forget it, like I just don't memorize it?
By part.
Integration by parts, right? U of v minus the integral of v dx.
How about that?
You got the skills, I'm giving you the skills.
That's false.
So if you fall in the water, you don't drown. Okay?
Here.
Alright, so let's try this guy, this one's gonna be fun. So plug in 1, 1 ln of 1, so that's 0,
Yeah.
minus 1, okay, minus a ln of a minus a. Yeah,
Calm down.
Sorry.
Just kidding.
limit as a approaches 0 from the right.
We have an issue.
We have an issue? What's the problem?
Plug in 0, undefined.
Plug in 0, we get 0 times ln of 0. Minus 0. Well, 0 times
Yeah, zero.
anything is 0, right?
Yeah. No
Like
issue ever.
infinity minus infinity is 0?
no.
Right, to some of you?
They're both constant.
No? Are you sure? Should we check on the calculator?
Yeah.
No.
Infinity times.
Let's check on the calculator.
Is zero.
0 times infinity.
I was sleeping on like Ivy's
Oh.
feeding.
0 times infinity, undefined.
Why?
Infinity minus infinity, undefined. What? I thought 0 times anything was 0.
They lied to you.
Interesting.
Why? This
is 0 times ln of 0, right?
Yeah.
So, what is ln doing as I get close to 0? Now that's what I have to consider. Where is he going?
Negative infinity.
So ln of 0 would actually be does not exist, but we can put a value there. We can put what? Negative infinity, right? So that's why some of us were saying 0 times negative infinity, but that's still not 0, right?
Nope.
Okay. But this is something that we would consider indeterminate.
Oh.
Okay? So when something's in indeterminate form, remember that you can apply L'Hopital's rule. Okay? So we're gonna apply L'Hopital's rule, but we have to rewrite it in a way to where it's a fraction. And then we can apply L'Hopital's rule.
Same.
So we're gonna L-hop it. Ooh! Oh, get it? We're just missing the AL, so might as well put it right.
No, it sounds cooler.
L-Hopital. There's an S also in there.